Good morning. How's it going? How is everyone? Sorry if there's a little background noise. I got my heater going. It is getting cold. Winter is coming. How's everyone doing this fine Friday? We're back. We're back working on our ECS here for our FTL-like. Had some thoughts. We can get into those. Sorry we're starting a little late here. We'll go a little long just to make up for it. We're getting ready for daylight savings time, which is kicking in over this weekend. I say kicking in, I should say kicking out. It's ending this weekend, so next week this won't be 8:48, it'll be 7:48. It'll actually be early, so think about that. All right, we're here, we're focused. We have some energy left over to finish out our programming. I want to start by describing how we were talking yesterday about how a component could essentially be an entity, which is itself, has its own components, and that those, because they're entities and they're stored, they're stored on their own archetype, they're sparsely stored. This part of the diagram I don't think totally sells it, because it's not just a pure component whose type is entity. We actually need a component whose type is this specific entity, this specific entity, not just the concept of entity, because normally a component's type is, it's like you're a type of position or a direction or a whatever. But for this case, its type is not just an entity, it's this specific entity. So we need to rethink this a little bit. And we're doing this to capture the concept of entity relationships. So here's our regular entity. It has two components. Let's just say it's a position and a direction. So it's a thing that has physical space, it exists in space and it moves around. These can be stored densely. It's dense, it's in the dense storage. I'm gonna add that dense storage because they're just regular components. This is sparse storage, so this is not stored locally. Densely in the chunks, So here's how we're actually going to do it. So this relationship is going to be captured by this entity. This is going to be like a short-lived entity that's existence just models a relationship. So we have our top level entity here, which we've decided has like a position and a direction. So it's moving through space. So maybe it has a target. So this relationship is a target. And so this is a target entity. And because it's not something that can be known at compile time, it's a specific entity, this entity will have a tag component, which is like this is a target because it's a component that doesn't have a payload. Like it doesn't have, like a position and a direction both have a vector 3 value that is associated with it, which I should actually probably add to the diagram. Value fields, maybe something like that. Put that in here. That's what makes a regular component. This is a tag component. So this component just is defined entirely by its type. So it's like this is a target, for example. This target has a relationship to this entity which is included with it. So the target here, the tag defines the relationship. Maybe it's child of, parent of, target. And then this entity is the, you know, quote unquote target of that relationship. The entity for whom the relationship is defined with us. And so this combination of components, this specific entity and this specific tag, form an archetype that this entity captures. And then this entity is added to the archetype of our top level entity. But because this is its own entity, it's stored in its own archetype. So it is in the sparse storage. It is not stored locally in the chunks the same way that our dense storage components are stored, because it's stored off on its own in its own chunks. And this has a number of advantages. One of them being, let me get my big head out of the way here. One of them being that let's say this entity dies. Let's say a bunch of different ships are targeting this entity, and this entity ceases to exist. Well, that's fine, because we can actually query for a list of all entities that have this entity component as part of its archetype. So we can go through, clean up all the references to this entity, not have stale references, because we're treating this entity as if it was a component, using its entity ID in place of like a component ID. That should be pretty good. There's some other ways that we can model relationships that's probably more clever. Like Sander Mertens has this very clever way of doing it, involving this bit set stuff that he does, where he's got like component entity ID or a relationship target ID, and then a relationship. So he's using the upper and lower bits of a single number, which, you know, that's an optimization, and we're not at the optimization phase. We're just going to capture this information very simply and do it like this. And I think that'll be fine. I think that'll be pretty good for us. So we can kind of start working on that. We're still working on how we're going to structure our chunks in what we're calling collections at the moment, but I don't like that word for a collection of chunks. I might just call it chunks with an S. I don't know. Venom weed. Oh no, it's like layers all over again. No, this is layers. We're using layers. This is the definition of layers. Because this entity diagram could just keep going. Like this entity could be part of a relationship with another entity above it. Or similarly, this entity could have a relationship with another entity below it. So this is layers all the way down. No, that's OOP. Yeah, well, our objects are being assembled dynamically. So yeah, this is like a component pattern, which you could implement without the entities. The entities could just be objects. We all end up in the same place, which is a game held together by shoestring and glue and duct tape. Only Greb, thank you for the follow. How are you doing this fine day? Happy Friday, if you are someone who observes the weekend. I've definitely been, at points in my life where I work all weekend, so I feel it if not. I always hated when people told me happy Friday as I was standing behind like a retail counter. That scared you? You were like, is someone at the door? No, that's the classic Star Trek chirp, the communicator chirp. You observe Fridays, pandas, then happy Friday. Happy Friday to you. But yeah, I'm pretty happy with this model. I think this model finally Obviously, we're losing some of our benefit of ECS if we're calling out to sparse storage for these relationships, but again, we're not, part of the reason we're picking ECS is not for just raw speed and power. Part of it is because I like this way of modeling things. I like this from a design constraint standpoint. The only thing that's a little interesting here is, when do we go through this? I understand a little bit about why Sander Mertens does it this way, where you have this primary identifier, which is the component entity or the relationship target, because then you can go through and you just tack on the, well, you tack on the relationship. Because, like, we need to know, oops. Because some relationships, like if a child of relationship would get processed in the transform system when we're handling positioning, right, and movement. But a target relationship, like an is target, or even targeted by, you know, that targeted by might also be in the movement system, but an is target relationship that could affect AI, that could affect like a weapons system. So the only problem that I can see right now with this structure is if the tag component is down here and it belongs to this entity, then we can't actually see it directly. We would just have to process all of the relationships for our entity and then scrutinize which ones have the tag component. Maybe that's okay. Maybe we need to reverse this relationship. So we would actually just search. We would just query for all tag components of certain kinds. We'd be like, give me everyone. Oops. You'd be like, give me all the tag components that are child ofs so that we can process them, or no, parent ofs. So give me all the parent of tags so we can process the movements of the parents first, or something like that, or I don't know. Whichever way is the correct way to do that for a hierarchy. So maybe this is fine, and I need to reverse the way that I'm thinking about it. Because then we'd want to grab this entity and go get its components. Oh well. That's fine. That's something we can refine. We can refine how we're structuring this. Bach Shadow. Okay. So entities have storages, which some are situation shifts. I mean, entities don't technically have storage. Entities belong to an archetype. Technically, the archetype has the entity, because you have the archetype so that you have all of the... So an entity that has all of the component types, like all three of these component types, will be stored here. I could actually even just add a fourth one here. This one's not component type, this one's entity. We've said entities are a kind of component type, but let's think about it this way, because it's like an entity will be stored alongside all of its dense components here. So they really belong to the archetype. I'm modeling it here like this, just because we're focusing on the entities, the structure of the entities right now. But how's it going, Fox Shadow? I really liked your last devlog. The UI is looking so good. For solids, archetype is like a recipe. It's more like archetype addresses a particular problem, which is a sorting problem, which is that if you have entities and not all of the entities have the same list of components, you cannot sort for them very easily. So if we have something like this, we can't just have one list of components and then just fill in components as needed. You need some, you can't sort for this very easily and process them contiguously. So you need to break them apart into their specific types so that we actually only store the components that we need for each entity so that we can have contiguous, densely packed stuff. But Versailles, welcome to... My cam is out of sync? By like a lot. That's kind of beyond my ability to fix, but let me see Versailles. Let's talk about what FTL is. Actually, let me not open my Steam. Let me just look it up here. FTL. Yeah, kinda. Sync looks good on YouTube. Okay, that's maybe just Twitch being weird. I'll look into how you adjust that, because I'm not sure how we would adjust that. It opened anyways. Yeah, Steam. I have this fast new gaming PC, and it opens everything and runs everything at incredible speed, but for some reason Steam takes like 15 seconds to open, and I don't understand. But yeah, FTL is like a top-down kind of Star Trek simulator made by Subset Games back in 2012. It was kind of the part of the roguelike explosion. And we're kind of doing our own take on it. So FTL is all about managing your ship systems, like your shields, your weapons, your oxygen, your engines. And it's about managing your crew who repair and, you know, they might fight intruders. They might board enemy ships. Repairing systems and stuff. Oh no, we blew up. And so it's kind of a Star Trek kind of simulator deal. And we're working on one that's kind of more isometric, that's a little more side on. Really good game. 95% from almost 60,000 people on Steam. But yeah, we're kind of doing more of a kind of side-on isometric kind of version. You reloaded, it's fixed. Oh yeah, I have to do that all the time. If I watch a Twitch channel for more than like 20 minutes, 30 minutes, I have to reload it. Looks like Stardius. Yeah, Stardius is incredible. I love Stardius. Yeah, Stardius is also kind of a similar take on that, but maybe more. Stardius has more of a RimWorld bent to it. It's more of like a simulation. We're going for more of the roguelike thing, but we definitely want some of that simulation stuff in. So, at the moment, we've just really got tools. We're just building up our tools for making this game. We're working on ECS as our main thing right now, but we've also got like this shipbuilding system where we can, you know, lay out decks and fill in rooms. Put in doors. Let's put an airlock here. It's really primitive what we've got going on here, but perspective is hard to manage sometimes. But yeah, we've got this whole auto tiling system, and we've kind of split our game state from our rendering state. So we can just build these three-dimensional structures that will eventually be ships. Right now they're just like flying housing projects. I need a lot more variety of components that I need to draw and implement. Right now we just kind of have the bare bones auto tiler working, which in isometric is not trivial. But yeah, I'm pretty pleased with the auto tiler. Yeah, it is. It's not even isometric. It's like lower than isometric. It's 4 pixels across for every 1 pixel down, whereas isometric is 2 to 1. So it's kind of like we got more of, hey, Ferlansky, how's it going? This would be a traditional isometric view. We're going for this, which is technically called a dimetric view. And I'm doing this so I can kind of draw the people from a more side-on perspective, because this is way more top-down. Okay, stretch from Ferlansky and a hydrate from Doodliest Catch. All right, let's do this. But yeah, this is kind of what we're working on. I've already got some new ship parts that I want to throw in here, some more angular pieces, but we can't really support that right now, which is part of the reason why we're refactoring everything. I want to add a lot more variety of hull pieces that we can combine together. Let's hydrate on. How's it going, everyone? How's it going for Lansky, Doodley's Catch, Versales? So you're instead going, instead of looking at 45 degrees, we're looking at like 20 or so. Yeah, approximately 20 something. Going good. It's your birthday today. Happy birthday, Ferlansky. That's amazing. I'll give you a quad door for your birthday there. That's from me. I hope you have better things planned to do than hang out here with us. The best gift? Yeah. You're welcome. Can't remember playing a game that uses this approach. Sounds interesting. Yeah, I have not actually seen a game that uses this perspective. It's kind of unusual. It means our backgrounds are kind of in perspective, but our foreground objects, like people, are like pretty much drawn side on, almost like a pop-up book kind of deal. There's this kind of difference between the two. What was I gonna say about that? Yeah, it forces us to do some interesting things about visibility. So let me just make a room here. Because the problem for us is that our walls really block a lot of the space behind it. So we need these cutaway systems so that we can actually see things. So we can actually peer into the ship. That's our big problem, is like visibility issues, really. So this is our current visibility system. It's not perfect, but I think it's okay. Quad doors coming soon. You're still working today? Pub dinner tonight? Nice. Got next week off work. Ooh, a whole week. That's great. How many steps is that? I don't totally understand the context of the question, Venom. Versales, would be better to hide all walls in the floor you're currently viewing. Maybe. I might give that as an option, but I kind of like right now the walls are really boring, so that's like a reasonable choice, but like there's gonna be like detail on the walls. There's gonna be like computer panels. stuff you need to interact with, decoration and stuff. So I don't know. We'll probably have a mix of like, because like if you put my mouse cursor behind it, this will happen. And I think that's like a little too much. I don't know. We'll try some different stuff. Once we got things running around, it'll be a lot more clear. How many steps is that? The isometric tiles you meant? So like, why do I keep opening the wrong file? There we go. So I mean, typical isometric is over by 2, then down by 1. We do over by 4, then down by 1. So it's a 4-to-1 instead of a 2-to-1. If that's what you mean. If you mean something else, let me know. I love that dimetric is the same as Digital Iliad. I kind of love that. It's like I'm looking at my own logo here. I guess you could say dimetric is... No, because ISO. It's isometric, dimetric. Yeah, I love that. What a weird coincidence. Matches our little logo. You could like let the decorations visible and the wall itself be invisible. Maybe let the monitor and decorations floating. Yeah, I've tried doing that with like the wall, the doors. The doors like didn't turn fully invisible. They turned like half invisible, so you could still see the doors. I don't love that. Or make the walls have a lower alpha. The walls being semi-transparent is maybe a good option. At a glance, we'll have to see. We really need to have people running around, and we need to be like giving orders. That's what you were asking? Okay, yeah, we're 4-to-1. Disometric. All right, so I'm reasonably happy with this construction for now. I think it's gonna get a little weird, and we might want to flip some of this a little bit. We probably eventually want to make it so that this can be just a component and doesn't need this entity intermediary, because we need to be able to get this tag component up here at this entity. So maybe this isn't correct either. Maybe it does need to be more like this, where an entity feeds into a component. I guess the entity would not... Here's my problem with this, because this is the alternative here. Let's do this. So the type would be like whatever. It would be like a tag of, or tag child of, tag whatever. So we add, you know, the value fields here. Here's the problem. So if the entity is not the type, but instead the value field, then I can't really query for this. I can't like say, give me all components that, you know, give me all components of this entity. Give me all references to this entity. Which I guess we don't strictly need. We don't strictly need this because an entity ID is a version and an index. So I don't actually need to clean up the entity reference. I just would need to have a check to make sure that we're referring to the same entity. Because we could have what I would describe if instead the entity forms the type and the value field was like target of or whatever. Okay, maybe it's this. Maybe it is this. Maybe I'm wrong. And then this doesn't actually need to be stored sparsely anymore. We could get rid of this concept of sparse and dense storage here. Move this up. Maybe this is better. And its value field is this entity. Oh, come on, buddy. There we go. Maybe it's this. Maybe this is correct. Maybe this is the correct format. It's probably this. Because while I couldn't just say get all references to this entity, I could say get all entities that have targets or that are targeting something or, you know, is a child of something or parent of something. Yeah, I think we want the component type to be the flag or the kind of component that it is. And the value field will be a reference to an entity. That's more in line with what our ECS guru is doing. It's probably more correct. Is this music too chill? I feel like I'm on like a meditative journey, which I kind of am. Yeah, I feel like maybe this is wrong. This obfuscation, this indirection of this entity that exists only to define this relationship, and then burying the actual nature of the relationship beneath this entity is not good. It makes it impossible to scrutinize from this entity without searching for all of your other entities and to find this tag component. So this is wrong. Okay. This is definitely wrong. Let's go back to doing something like this. I think this is correct. Music's great. Good. Glad to hear it. I figured I'm kind of tired. I figured everyone else would be kind of tired too. We kind of just slow roll our way into the weekend today. All right, I'm pretty happy with this concept, with this conception here. There's a question of what the distinction is between the ID and the type. I honestly think the ID and the type together form the identity of the component, in which case the ID itself, if we don't actually have entities as components, if we actually remove that as a thing, no, we're still going to have entities as components, huh? Maybe not though. Maybe if we have a component, it says like ship, and then we have a value field and it's the entity. So the ship that we belong to is this entity. Yeah, maybe the component ID is... Oh, the component ID is probably just a shorthand for comparisons. We probably still want it. But it seems like maybe a component is going to still be an intermediary between direct connections between entities. There's so many ways this could go. Let's fix these real quick. Box Shadow, Simba. Simba. Everything the ECS touches will one day belong to you. I Heart Pandas beaming up with the tier 1 sub. Thank you so much. Thank you so much, Pandas. I really appreciate that. This will all be yours? No, this will all be mine. I'm mixing my metaphors here, but I'm not doing all of this just so I can give it to you. I mean, unless you are the player, eventually, then yes, all of this will be yours. Or a modder. But first, it's going to be mine for a few years. Okay, I'm happy with this. All right, let's actually do some coding. Let's stop messing about. Writer detects naming conventions and opens solutions and updates settings accordingly. Click configure to change. Configure. What's your opinion? Methods, upper camel case, yeah. Instance fields, lower camel case, yeah. Parameters, lower camel case. Is this not default? I feel like this is default. Just gonna just use default rules. Does that correspond? Oops. These seem identical. Why are you talking to me about this? These are identical. Writer. There's like no difference between these two. Writer is a little too opinionated sometimes. All right. So, what are we working on next? Probably the archetype, probably structuring the archetype. All right, so we've got our iMemory owners, which we added last time. These are the references to the memory that we're renting, which forms our individual chunks. These memories are rented from a memory pool. They're cast to spans or read-only spans of a specific T based on the item type that the chunk represents. We have an item count, which is important. The archetype also needs to have a maximum size. I thought I put that somewhere, or did I put that here in the collection? I put that in the collection. I put a per chunk max because unfortunately the chunks I want to say that call this max items per chunk. Maybe max chunk items. I don't know. There's so many ways to write this and none of them are very clear. Collection needs to know its component. It's got a list of chunks, which is its chunk list. What does this have? This just has an item type that's a file struct. That's correct. Component, it's got its component. The component, which I should probably rename because component here means component type. So you'd get component, you'd get type. It's type and ID. It compares itself to others using its ID. Let's make these all the same here. We've got built-in components whose ID we are statically declaring, which is kind of why I feel like components don't need IDs. They could just compare themselves to other components, just being in like is a direction. Actually don't think we need an ID, but No, maybe we do. Maybe that's easy. Maybe that's easier. I don't want to be keying into dictionaries using like type of whatever. ID is straightforward and easy. Entity has an ID and an archetype. All right, so this is what we're working on right now. The world, which holds the list of archetypes. The archetype, which holds a series of collections per component. And then a chunk, which holds a contiguous block of memory of a homogeneous component type. So we need to start adding some functionality to this stuff. I think we have most of the bits that we need. If we do a query, we basically send them a list of collections. So should a collection have a reference to its archetype? Because someone might grab the collection and not have the archetype. Yeah, we should probably do that. Similarly, a chunk should probably have a reference to its collection. Probably, maybe not. I kind of want to keep the struct because chunk is a struct. I want to keep the chunk as small as possible. I actually don't even know if a chunk needs to know what its item type is. Probably should. For safety reasons. Let's initialize all of these, probably a good idea. I don't know if Writer does that for us, but I'm gonna do it explicitly here. You can just change this to this. So a collection might be moved to a new archetype. It's actually good that the collections are classes. If an archetype, if we need to move all of the data of an entity, like if we do a mass assignment, because at first we're only going to support single entity assignments, entity component assignments, but eventually we're going to have like, you're going to be able to be like, change all of the add a component to all of these entities. And that'll be a pretty involved process, and having the ability to hold these collections separately and just swap out the archetype seems good. Seems good. I will change this name. I think collection is a terrible name for this. Call it like dense storage. I don't know. No, component storage. I don't know. Here we have it, we call it component chunks, which I think is fine. I'm gonna rename it collections for now. If we come up with a better name, we'll change that stuff out. Its composition is a list of components. I don't know when that's gonna be useful, but it'll probably be useful somewhere. What else do we got? We have archetype edges, which is a way to graph where an archetype is. So if we have an archetype and we need to know where the next archetype is, if we add or remove a component, we need those edges. So that way we can know, if you add the component, you want to get this archetype, because it's basically this archetype with this component added. So it's a way of caching the result of those searches if those archetypes already exist. So that's good. That's a good thing to graph here, the archetype edges. Could call that like an edge graph or something like that, or an archetype graph. Should probably call it an archetype graph. Probably call this plural archetype edges because it has 2 edges. There isn't a huge idea today. We're kind of just chipping away at stuff. Archetype graph. Call it graph edges. I don't know. Start probably fleshing out this functionality, like our add component. So I'm putting all the functions just in our world, which is what holds all of the archetypes and stuff. I don't know if I want to keep it like that forever. Maybe we add like a manager, who the manager is the only one who's allowed to touch the single instance of the world here. Because there's only a single instance of the world and it's kept on our root node, our game node. It's going to keep a world instance and it's going to keep an input instance. And right now we're just going to directly call into the game world, but we might want to add some protection there eventually, or some limit the access. Here's the structure. The game has a world, the world has archetypes, archetypes have collections, and collections have chunks. So I think this is all we need to get started as far as defining behavior. Like how to add entities, remove entities, add components, remove components. Sorry, I'm getting like blown up on my phone. It's like mostly election spam mixed in with actual things. Okay, so yeah, let's just start with this. Let's just keep working on this stuff. So let's do an add component. So the way you do this, so we've got a couple of helper dictionaries here. We've got the archetype components. You can plug in an archetype and get a set of all the components that are in that archetype. I don't know why it's a hash set. I guess it's to make searching easier. Because you don't really need to iterate over it. You need to search through it. Plug in a component to get a set of archetypes and include that in component. Yeah, here. So this is something, these are things we need to manage. We need to add and remove things as we do this stuff. So you can have a component and find all the archetypes. And then here's a thing where you can plug in an entity and get archetypes. I don't think we need this, because if you have the reference to the entity itself has a reference to its archetype, which I think is fine. I think that's a fine thing to do, even though it's a struct. And I don't want to bloat these with structs with references. I think an entity directly knowing its archetype is quite good. Can simplify a lot of lookups. But this interface. How? Okay, forget it. Yeah, I don't know. I'm kind of torn on that. 'Cause keeping a dictionary here of this is kind of annoying, but I'm not sold on this. Because the entity is never going to be the largest thing because it's just an ID and a reference. That's like the smallest possible component. Virtually every other component that's not a tag, and tags don't need to be stored. Virtually every other component is going to be larger than this. Because this is just a single integer. Like reference, yeah. Oh, maybe the ID on a component, on a specific component, is a reference to its entity. Because if we're queuing, if we're querying and we get back a list of directions from a query, we're not going to also get back a list of entities. You would need to be able to find the entity from here. So maybe these IDs are not static, and these are actually the IDs that correspond to the entity that it belongs to. That makes a lot more sense. I was like, why am I putting these here? Public ID. Why is this red? Make all that, right. Why does it want to rename this? Parameters. Parameters is lower camel case. That's what I'm doing here. And it's complaining about it, saying it's inconsistent naming. I'm just gonna turn some of this off. Are you gonna go away now? Inconsistent naming? Yeah, forget this. I don't want inconsistent naming. Inspection. It's like more annoying. I can't stand when there's these little like yellow things here. Now what are you yelling about? Non-access positional property? Okay. What does that mean? I am accessing. I'm using in the constructor. C#9 record syntax defines a bunch of members implicitly. Yes. Properties corresponding to primary constructor parameters and the deconstruct method. Oh, properties corresponding to primary constructor parameters. Oh, so I don't need to declare these. Is that what you're complaining about? These are both accessed. Type member is never used. Oh, what? Oh, so... because the equals is based on your value. So we don't actually use your ID for anything. I see, I see. I maybe need to re-implement an I-equatable for an entity if I want to be able to compare a direction with its entity, so we match IDs. And I want to do that in a way where we don't box, so I would do it with a T. Do I need to re-implement an I entity interface? No, I can just say entity. Let's see if we can do this. Equatable entity. Turn ID dot equals other dot ID. Here we go. Should be fine. I get rid of these. Is this what it's telling me here? And then this is what it wants me to do. It wants me to declare these as properties in the primary constructor. I see. I see. Super weird. Kind of getting used to record structs and everything they save me from having to do myself. I think I need to override the object one though now. Public override equals object. Override void. Override bool equals. Let me look at record structs for a second here. See what I need to do. Yeah, I need to override this. Because we compare ourselves to different things different ways. Why are you upset with me, Ryder? Remember with the same signature is already declared. Yes, I'm trying to override it. Who cares? Doesn't matter. Let's do the same thing for position though, because position's gonna yell at me as well. So we can get rid of these because these are implicitly in the. These are implicitly here. Primary constructors are weird. They're kind of cool. They definitely save some stuff here. Equatable entity. All right, that seems fine. Those are kind of the only built-in components I've defined yet, position and direction, because they seem like good examples, and they're pretty straightforward. All right, let's start adding and removing components and stuff. So we don't actually need to do this lookup. I'm actually not convinced we need this lookup at all. Instead, we're going to look up entity archetype. There we go. And we're going to search the graph edges to find this component. If we are able to find it, archetypes need to have IDs. They currently do. But do they need to? That's the question. Also, can I just simplify this? I kind of like being able to count the usages. I can't count the usages when they're up here. Okay, are you upset with me now? Ambiguous reference, where? 29. Archetype other. And ID equals other dot ID. Oh, okay, so you don't like doing it this way. Maybe we're gonna have to undo some of that stuff. Oh, because you're not a record struct, you're a class. Oops. Oopsies. All right. All right, so our new archetype is edges.add component here. Instead of checking to see if it's a null, I should probably check to make sure it equals how am I going to do that? Because archetypes are probably... Oh, should an archetype ever really be recycled? Probably. They're just classes. They don't really store anything themselves. They could clean up their own collection. If they clean up their own collection and they get rid of all of the memory and the chunks, the archetype could just sit around representing a composition. Even if we're not currently using the composition, I could just keep the archetype around. I don't necessarily need to get rid of the archetype. It's probably better if I never get rid of an archetype once I've created it. Otherwise, we need to do a lot of like checking to make sure that this archetype has the same like ID and version, the ID version, that it hasn't been incremented. Which is tough because it's a reference, so if we're passing it around by reference, then we won't know what the previous version would be anyway. So yeah, let's just do that. Let's just see if it's not null. This check doesn't make sense, because if it's in the graph edge, it's not going to be null if we don't get rid of it. Yeah, we're going to do this differently. We're going to just say, move the entity over. And then here in the else, so if we aren't able to get the component out of the graph edges for this archetype, that means we've either never searched for it before or it doesn't exist. Well, no, it by definition means we never searched for it before. So what we need to do is we need to search for the archetype, as I wrote here. And if we are not able to find it, then we need to create it. So we search for it by, what's the easiest way to do that? Plug in a component into the component archetypes. Okay, here's the situation where we're just iterating over this hash set here. Dude, Lee's Catch, how long have you been working on this? This ECS system, like 2 weeks, maybe. It's been a lot of remembering how C# works and then deciding how we want to store stuff. Like, even just settling on memory T and span T, like, was a while. Which is a little embarrassing. But yeah, I haven't used C# for a long time, and back when I did use it, it was in Unity, and it was a very different C#. It had much fewer of the features that this current version. I'm on what? I'm on .NET 8, which I think is the highest .NET version that Godot supports right now. Doodliest Catch, you're a bit of a noob when it comes to this. Only made a side scroller on Godot. No, yeah, for sure. I'm not a huge expert on Godot either. I've made like a 2D game and a 3D game in Godot. I haven't done anything this complicated in Godot. Afzatal. Hello, welcome to YouTube. Welcome to the YouTube channel here. Appreciate that. You're a filthy UE5 user? That's fine. There's nothing filthy about UE5. UE5 is cool. UE5 is like hardcore. High fidelity. That was one of the first things I mean, obviously not UE5, but the first two things I did when I first got interested in game dev was I just started making levels in Unreal Engine and in the Source engine. I think I preferred the Source engine for some reason. I don't know why, probably because I just loved Half-Life so much. For Lansky, you had to drop off for work, but now it's the weekend. Hell yeah. How we doing? We're doing okay. We're deciding about how we want to search for archetypes that have a specific set of components. I have a hash set here, but I don't understand why it's a hash set. I feel like it could just be a list. Because we don't have a key to plug in here. We're just gonna iterate through them and figure out which archetype has the set of components that we want. So when we create an archetype, we have to make a new list here. Well, it doesn't need to be a list. This doesn't need to be a list. This could be an array, because this isn't going to change. It could just be an array. Oh man, you'd probably like playing with the Source engine. Yeah, the Source engine was super cool. I don't know how it is to use nowadays, or if it even is being maintained at all, but super cool. Aftal, you're making a 2D game in UE? Oh, interesting. That's an interesting choice. Part of the reason I hopped over to Godot was just how good Godot's 2D support was. Oh, not because it's getting 2D, just because you're so used to UE. That's fair. That is a fair reason. There's a fair reason to do it. Lansky, you're note-taking now. You tried making a vector2 equivalent that used bytes instead of floats, and it really didn't work. That's an interesting thing. Why do you want that? Is it you're thinking about this whole like I'm grabbing a arbitrary chunk of memory bytes and I'm casting it to a span? I mean, I don't think that's a great example of how you'd want to make a vector. We could probably use this to make a vector of arbitrary length. Oh, but we don't need it. We're just going to use arrays. This is basically an array maker under the hood anyway. Memory. You messed with Godot, it's so much better for 2D. Yeah, pixel perfect, having pixel perfect physics, pixel perfect rendering, pixel perfect collision. It's like so, it makes UE and Unity look like they're really slipping as far as their 2D support. I don't know about Game Maker, I've never used Game Maker. You have a small team that you manage and you all have a ton of UE experience, so it's hard to justify switching in. That's so fair. Philip Rank, welcome to the YouTube here. Why am I using C#? Let me tell you why. Let me open the right window. So we're kind of making this FTL-like Starship kind of game. Frelansky, Minesweeper, grid spaces do not need decimal values or big values like vector 2 int. Oh, 0 through 255 is enough. Yeah. Just use... Yeah, I don't know how you would do that. I was about to say use packed byte arrays, but that's probably not a good idea. Maybe it is though, because you know the maximum size of the board probably. But we have this shipbuilding tool that's very bare bones right now. But it has a couple of things that it lets us do. It lets us auto tile, and it lets us rotate. So we have actually, the rotation is significant because it symbolizes how we've separated our rendering data from our game state. So this tile map is just a view into our game state. It can just change. A lot of times you'll see rendering state and game state are like very tightly coupled, especially if you just have like a game that, I mean, it's actually just typically very tightly coupled, but for us it's separate. So because it's separate for us, I want to put the simulation layer outside of the scene tree. I want to do all of the game simulation stuff in script, and then just pass whatever I actually need for UI and rendering to Godot, to the scene tree. And if I'm doing all of that scripting, I should really just be doing it in C++, honestly. I should just be doing that, but I'm not. Like Axfowl, I'm using C# because I'm more comfortable with it. Even though I did just say how I haven't used C# for a while, I am still more comfortable with C# than C++. So we have this flying housing project maker, basically. We've got a bunch of new pieces that we can add that I haven't implemented yet because I'm kind of preoccupied with this. But this is going to get a lot more feature rich. But yeah, so our kind of approach is that we have like our auto loads here, like our input handler and stuff like that. Take input. We have a scene tree. We have this game manager type that is at the root of the scene tree. And it's the only one that's a node. And it takes that input. It runs, these managers are now systems. Since we're kind of doing ECS, we should call these systems. But we run like a state system that figures out what state we're in, and that, depending on the state, might run other systems. To run other systems. And then eventually we get to this like scene system or scene manager that will just either update or put the scenes back or instantiate and remove scenes that we need in the scene tree for UI pickability or rendering and stuff like that. And then if they're UI pickable, they can pass their inputs to the input handler, who's an auto loader. and we start anew. And so we've kind of taken this whole chunk, the whole simulation layer chunk, and just broken it out into C#. So it's not backed by nodes or resources anymore. That's kind of what we're doing and why. And then additionally, we're kind of doing an ECS because I'm insane. Because to me, every problem is a nail, and ECS is a hammer. But no, it's because we're simulating a lot of stuff, and I think it's an easier way to assemble and run stuff like that. What are you, I really appreciate the positive feedback there, guys. What are you using to make those diagrams? We are using Obsidian. We are using Obsidian. Obsidian is great. I think it's free. I don't pay for it. It's like kind of like an alternative to Notion. It's got a lot of note-taking tools, but it also has like graphs and canvases. Canvases are like the coolest thing about it, because you can kind of see here, canvases can include all sorts of stuff, pictures, text. What's really wild is that if I wanted to, I could just add a web page. Let's just grab, like here, like if I wanted to take the Godot docs into my canvas here, we can just have a functional interactive website as one of our little canvas windows. So you could do all sorts of wild stuff with this. It's really cool. I really like the Obsidian canvas feature. As someone who I don't really have Figma or Notion or any of that stuff. And I'm more a programmer than anything else, so I'm not like doing these big artsy diagrams, but I've started getting into more system diagram stuff. It's really helped me. It's helped me understand it, and it's also helped me explain it. It's so hard to explain this stuff to them sometimes. For Lansky, you wanted vector 2 byte because instead of storing every grid space in an array, you wanted to just store the grid spaces that contain interesting things, so you don't have to store a load of nothing. Ah, I see. I see. How would you do that? I mean, that's such a small amount of memory. I feel like I would just store the whole grid. Because if you store the whole grid, you can store the whole grid in a single packed byte array that's flattened. Be super easy. Yeah, that's probably what I would do. I'd probably just eat it because I mean that's obviously what I do. Like that's why I'm declaring chunks that are all 16 kilobytes, even if we don't need the whole thing. Because to me, it's just easier to declare the memory and then use it as I need it. That's what Cubus would say. Cubus would tell you for Lansky, like, do you really need to save 255 or 256 times 256 times 8? Do you really need to save 500 kilobytes? Are we in an environment where 500 kilobytes matters? Yeah, get your own. Cubus is my workflow guru. You never knew you could make technical diagrams in Obsidian. Cook. Oh, you said cool. Man, you almost sounded really hip there, Philip. You almost sounded like a Gen Z or an alpha. Yeah. And then you had to be like, no, I mistyped. I did not say cook. All right. I would normally wrap up around this time, but I actually have a doctor appointment in like an hour and a half, so we're gonna stream for another like 40 minutes. We'll hang out for a while longer. All right. We're gonna actually add a function that does something. I think we've settled on our. I don't love all this. I think I don't need all of these, but. Chunk index can't just be an int, right? It's got to be like. It's got to be a chunk index. It's got to be a collection index and a chunk index. The collection should just store. Yeah, because we need two indexes now. It's not enough to just say, here's the index into the chunk. It's here's the index into the chunk, and here's the chunk that you're indexing into. I need to think about that more. Let's work through this and maybe it'll become obvious how we do that. You're not certain this is right, but you're thinking by just storing interesting places, iteration would be faster, since you're not iterating over every square, just the important ones. It depends. That depends, Furlansky. I mean, part of the argument of an ECS is that it's actually cheaper to just iterate through everything than it is to iterate through and like determine what you need to iterate through. So yeah, if you're storing everything super densely, yeah, so by that logic, yes. If you're able to do quote unquote existential processing and you only have objects that are interesting and that matter and you skip all the objects that don't matter, yeah, that's fine. But it's like, I think the question is just like, is that an optimization you need? Like, how long does it take to iterate through 65,000 items? The answer is not very long. But I get it. It would be better to just store what you need. Instead of having to iterate through 65,000 things. That is enough things where you might worry about it. For me, we're talking about ships that are like 19 by 19 by, I don't know, 7. It's like this super small, individual ships are these super small spaces. So for me, it makes sense to just have the whole thing there. Whatever justifies it, it makes the project more interesting. Yeah. But in that case, here's the thing. If you're going to optimize for that, don't worry about the int then. Like, I would argue that if you wanted to represent the whole grid with bytes, use a packed byte array. But if you're like, I'm not going to represent the whole grid because I don't need to, I just need to represent things that are interesting. Well, it's like, well, then just use a vector2i. Don't try to save memory space on making your own custom byte-based, byte-backed integer or a vector, your own byte-backed vector. But again, whatever justifies it, if it makes the project more interesting. If you're just trying to make if you just want to make interesting decisions to see what the consequences of the interesting decisions are, I am all for that. All right, we're focusing. We're getting back on track here. We're gonna make an add component function. So if we do find the archetype, we'll move the entity over. This should be relatively easy. If we don't find the archetype, like if we haven't searched for it, what we need to do is we need to find it. We need to find an archetype here. So we need to say something like, we would say else if component archetypes dot try get value. What is this? Try get enumerated count? No. Try get value. Component. Out. Variable. Comp archetypes. So if we can get that. So if we have a list of archetypes for this component, that's great. If we don't, then we need to create an archetype. Very true. You've gone for vector 2 for now because you're in C# and try to make that script engine agnostic. We'll circle back to the data type if it ever matters. For sure. Yeah, I use vector 2i just because I like it. It's like the one Godot collection I'm using here a lot. I like vector 2i. Or vector 3i is usually what I use, but I like their integral vectors. But yeah, fair enough. All right, so now we need to search for the archetype if we were able to get one. So what we need to do is we need to compare. We need to compare a composition. We need to make a composition and compare it with how do I want to do that? Do I want to just make an array? This is where it would be kind of cool to make a vector of arbitrary length using memory, but I'm not going to do that. What we need to do is come up with a type signature system for the compositions, but I'm hesitant to just hash them because hash collisions will make that kind of weird. Like, obviously, hash collisions are fine most of the time. But I just I don't want that to be an issue, so we're not going to use that to directly compare them. So we can then, so we get our component archetypes, and then we can just plug them into our other map, which is our archetype components map, to get a list of components. This is kind of silly, and we're probably going to come up with a better way of doing this, but for now, let's just do it simple. Let's not be crazy. If archetype components dot try get value. What are we looking for? We're looking for... Oh, we need to iterate. We're doing an iteration. This is kind of rough, but I guess if we have the archetypes, we don't need to do this dictionary lookup. We'll just grab the archetype, say like, what is your composition? This part sucks. I don't like this part where I'm like comparing a list of components to see whether you have the same list of components or not. That would be somewhere that would be nice to have a way of getting around that. It'd be nice if there was a more direct way of comparing those. I mean, we can make a composition a thing. And we could assign it an ID. Like we could make a composition like a first-class citizen. But it's like it is what an archetype is. An archetype is like defined by its composition. And we could just iterate through. We could just iterate through the component list and like build a hash for it. And that would be okay. It would probably work most of the time. I don't know how I would handle failures, how I would handle collisions, hash collisions. It's probably easier to just go through the list of components and compare all the IDs. That's probably the only real way to do it. That's foolproof. That's probably what we should do. Say variable new composition is entity dot archetype dot composition dot copy to. Yeah, we can do a copy to. I just want to declare a array that's bigger than the last one when I'm doing the copy. Can I do that? Copies all the elements of the current one-dimensional array to the specified one-dimensional array starting at the specified destination index, array index. I see. Oh, we need to keep this sorted is the problem. Does list have a good copy? Let's look at array. Let's see what we can do with array. Oh, it's an I list. I don't want to make it a list so I can manipulate it. Maybe I should just have it be a list anyway. Okay, list just copies to arrays. List doesn't copy to other lists. That's fine. I can copy it to a span. That's not useful in this case. That'd be useful in other cases. Technically do that instead of memory, but the reason we're using memory T is so that we can eventually change the source of the memory backing it easily. That's cool. There's a lot of stuff in here. What if composition was a list? I don't want to copy to a span. I'm trying to like make a copy of this .clone. That's not a thing. We need a better way of storing component signatures, which is like the list of components that an archetype is made of. We need a better way of doing it. I can't just add. Oh no, because it's an array. We could say size. We could say we can make a new array. Declare a new array. For remove, it's a lot easier. We would just trim the component that we don't want. But now we need to add one. This is again me like not being adequately familiar with C# here. Aren't you giving me thing? The array extends from iList. iList has an add. It takes an object. So if the iList has a fixed size, which it does when it's an array, we can't just do this. look at this as constructors. Where are the constructors? What? No, this is what we need to do. Where are your constructors, bro? All right, that's easy. So we are declaring component dent is a new component. This is going to be, here we go. Put it down here, and we're going to say old archetype dot composition dot length, yeah, +1. That's really stupid. So we're making a new array, one bigger than the old array. We're copying the contents of the old array over. And then we're going to add it's really stupid. At least Ryder knows what I'm doing. We'll probably come up with a better way of doing that. Well, at least now we have a new composition. Then we need to sort it. New composition dot sort. Oh, what? I could have sworn I saw the array class has a sort method. Oh, we plug the... We just call sort. I see. So instead I say sort, no, array dot sort. Component dot sort. Array dot sort, yeah, that's what it's supposed to be. Why are you yelling? Why are you arguing with me, Ryder? Probably just need to add a reference. Import type. System.array. There we go. We need to keep the component list sorted. For reasons that I don't remember. But I'm sure there's a good reason. This is a lot of bullshit to add a component. But the good thing about it, it means it'll probably be easier to add components in bulk to entities of the same archetype. Because a lot of the effort is just doing this, like preparing a new archetype. The moving of the entities should be relatively easy by comparison. Especially if we're moving like all of them. Do I necessarily need this? I only really need this if we don't, if the archetype doesn't exist yet, huh? Am I on my new schedule so I can stream later? Not quite. Still another week or so. I'm actually going to a doctor's appointment in like 30 minutes, so we're just running a little. We're streaming a little later. I woke up a little later. I'm trying to get a head start on daylight savings ending. Trying to just wake up a little earlier, or wake up a little later, stay up a little later. So I'm not totally confused next week. Yeah, I'm starting my new schedule on the 11th, on Veterans Day, on Victory Day. Or Armistice Day, I guess is technically the term. V-Day is like something else. V-Day is like a World War II thing. Armistice Day is a World War I thing. I'm pretty sure. I honestly am kind of fuzzy on history after like 100 BC. I'm pretty great 500 to like around 400 or 500 BC. I know my history pretty well. But the closer we get to modern times, the more rusty I am. All right. Well, we'll keep this up here for now. I don't think we actually need this. New archetype is edges.add component. This new archetype will have this composition already. So yeah, we shouldn't do this at the top because we can just save ourselves the trouble most of the time. Because most of the time these archetypes will already be known about and will already exist. We just need a backup for if they aren't. So this is if we haven't, this is if we have found it. If it exists and we know, and we've already tried to make this move before. This is if we haven't searched for it, so we need to search for it here. So that's what I was doing. And then this is if we just straight up don't find it. We just don't have... Well, this is if we don't have an archetype for this component at all, which is perplexing. I guess it's technically possible. So if we're able to find a list of archetypes for this component, this right here, call this component archetype. So we'll say for each variable component archetype in component archetypes. So we need to go through and we need to find this. Oh, that's why we're declaring this new composition. Because we need to be able to search for this composition. Even though we're getting like a list, which kind of sucks. That's fine. We need to iterate through it and see if they match anyway. That's also why we're sorting these, is so that we can search through element wise. There's probably a shorter command that would let me go through here. Like I really hope we don't have to then for each through the whole archetype. I guess that's like a binary. No, it's not a binary search because we're not searching for one thing. We're determining equivalency. Maybe I need a data. Maybe I need a data. Maybe I need a class or something. I really don't want to just keep adding classes that like wrap. That wrap things. That like wrap these lists. Maybe we need something. Because we essentially need to check every... compare every element of two arrays. Well, one of them's a list is the other problem. Maybe need to change that. I guess I could convert it to a list. Not comparing items, I'm comparing the items in a list. Yeah, maybe I do need a wrapper that just has like a signature or something like that that's easier to compare. Even if it is just hashing the lists. That will fail like 1% of the time or something at like low numbers and like higher at higher numbers. So I kind of don't want to rely on hash. I might have to think about this. I might have to think about how we're going to do this. Gotta run. Off to the pub. Good luck with it and have a good weekend. Thanks, Verlansky. Enjoy your celebrations. And your week off of work. Happy birthday. Got an ad in a minute. I'm gonna enter some deep thought once that runs and we'll figure this out. This is a list because we're just going to continue to add to it, which makes sense. It's a list of archetypes. So it makes sense that we iterate through this list of archetypes. But then each archetype has an array. Okay, so no, we just need to compare two arrays. There's probably an easy way to do this. Compare the contents of two arrays against each other. C#. A loop in the equality operator. That's it. That's like the way to do it. That's method 2. Sequence equal. Ooh. I would love that. Let's do that. Sequence equal. That seems good. Structural comparison, structural equality compare. Wonder which is better. It's simpler just to use the sequence equal. Let's look at that. Let's look at sequence equal. Probably an extension method. Music is giving Minecraft vibes. Oh yeah. It's like this random meditative radio station. Pretzel did the thing where it like seemed to like reduce the amount of music that I have access to by like a tremendous amount. Where's sequence equal? Sequence equal C#. Oh, it's enumerable. It belongs to enumerable. That should be fine. Using the default and quality compare for their type. And their type, they are filled with components. And components compare each other with their IDs. That should be fine. That should be fairly fast, actually. Okay. I should really rename this component type. I admit that it's getting confusing. Because this is component in the generic sense. Not like a specific component. It's like a generic wrapper over specific components that records the ID and the actual concrete type that it relates to. So for here, for each archetype in component archetypes, because component archetypes is the list of archetypes that belong to this component. We're looking basically for an archetype that matches this new composition. So I guess I do need this new composition, no matter what. Except maybe in this case, in this initial case. So if anything, maybe I can move this down here. Or do I need this new composition? I need the new no, because this archetype already exists. Yeah, so I need it down here. So we can skip this along the easiest thing. And we'd want to return before moving on. Svar, fair enough. All right, so that's what we're going to do. We're going to say component archetype if new composition dot sequence, let's say if component archetype dot sequence equals new composition. Oh, component archetype dot, let's say new composition. New composition. So if our new composition sequence equals component archetype dot composition, there you go. Why are you upset with me? See, is component not I enumerable? Is that my problem? No, it wouldn't belong to the component. It would belong to the array class, right? Maybe I don't understand. Enumerable. Oh. No, I'm just declaring this wrong. Class pet has a name and an age. Sequent equal x1. New pet. Pet 2. Create 2 lists. Equal is this list dot sequence equal this list. Isn't it dot equals pumpkin bread? No, we're doing a sequence equal because we're comparing the elements of 2 collections here. I'm doing arrays. Should I be doing lists? I feel like arrays should work. Yeah, arrays should work. After you implement this, I just maybe need to implement an interface. If you want to compare the actual data of the object sequences instead of just comparing the references, you have to implement the iQuality compare generic interface in your class. I need to just do that. I already have the equals. I already implement the equals. I just need to declare that it's... I feel like isn't... Hold on. iEquatable is like implicit, isn't it? You need to just implement the iEquality comparer generic interface. Yeah, I've already implemented this. But I maybe don't declare it. It's comparable. Do I really have to do that? So yeah, isn't this implied? It's a redundant base type reference. Yeah, I already implement these interfaces. That's weird. No worries, pumpkin bread. I am always happy if people are shouting out solutions to me, because I often have it wrong. We're still pretty rusty in C#, and we're doing something that's pretty... Oh, this isn't advanced, but we're making an ECS, which is not the best thing to be using, not the best use of our time, but it's what we're doing. But how are you doing? Happy Friday. Welcome to the YouTube chat. So I need the iEquality comparer. Here we go. Can I do this? What is the missing members of this? Oh. I don't know if that's going to fix our problem. But we can try it. Because, yeah, if it was going to fix our problem, even though they're not implemented... This should work. I feel like I should be able to just do this. Where did the thing go that was actually doing? Oh, here it is. This should sort it for us, having these. Yeah, we're supposed to implement the iEquality compare generic interface. When you say in my class, yeah, you mean this thing. Yeah, we implement this. Maybe I'm just declaring that incorrectly. They're saying it's this, but then they're also describing it as this. Sequence equal. So the super weird. Oh, this is in link. I don't exactly want to use link. What other options do we have here? I mean, a loop and the equality operator is fine. This kind of sucks. The compiler would probably make it fine for us. Probably doesn't matter. Structural comparisons dot structural equality comparer. Where does this belong? This belongs to the system collections. The iEquality object, compare object, returned by this property is passed to the equality comparison method of a collection object, such as whatever. Structural equatable dot equals iEquality comparer dot equals is called for each member of an array. Whatever, who cares? I'm just gonna implement a loop. Loop is dumb, but we're just gonna do it. For each variable, for each archetype and component archetypes. This is really stupid. Maybe we do this differently. Maybe instead of having it be like this, a list of all archetypes that include this component. Well, no, we need this. This is something we need, but maybe we don't want it for this purpose. Maybe for this purpose, we want a list of compositions. I guess that's not meaningfully different. You know, maybe instead of having a graph on each archetype, we just have a graph. And then we're not searching all this bullshit. Then we just check the graph, and if the graph doesn't have it, we haven't made it yet. Maybe we just keep a graph on the world, like an archetype graph. Maybe that's the way to do this easily, instead of trying to like search archetypes and like figure out. We just have a graph, and we just graph from one archetype via components to the other archetypes. And if the graph is incomplete, yeah, I think that's how I'm going to do this. I think I like that better. However, I need to go. I got to get ready for this. I got to get going to this appointment here. But this has been awesome. I really appreciate everyone hanging out. We're not going to be able to stream very much next week because I'm still transitioning to this new work schedule. But when we come back Armistice Day, after Armistice Day, we are going to be streaming so much longer, so much more often. We're going to be streaming like 3 to 4 hours a day. It's going to be great. 5 days a week, probably Tuesday through Saturday. I just need one more week. Just give me one more week of this kind of awkwardness as we sort out this transition. I'm gonna put a to-do here. To-do, make a single archetype graph for the entire world. Instead of doing this per archetype. All right, let's make that to do so I remember what we're doing. But yeah, I gotta run. Thank you all so much for watching. I hope you have a great weekend, and I'll see you next time.